Today we're mainly going to keep plugging away at chapter 8. See how far we can get. And I gave you, or the textbook gave you, a new spectrogram to work on. How did you do? It's tough, but let's put our heads together and see how we do. I'll open up the other spectrogram I made, which I do think is a bit clearer. Okay, it's a bit clearer. Let's go for what we can recognize. Start with what we can recognize. Remember, we've sort of been getting reminders all along about what we can head for first, what we can look for first in a spectrogram. And there are a couple things that we can already take care of. Step one is usually what? That's right. Do we have any of those? But are they s or are they sh? Let's compare. There's a nice comparison on page 205. Just to remind ourselves, we know that that noise pattern looks like some kind of a sibilant. It's either s or sh. But which one? It's s. It's not going to be sh, because for sh, what happens? We have more energy lower down, right? But we don't here, so that looks like s. So we've taken care of what? Four s's, right? Now that's quite a bit. So you already have quite a bit of information. And we also use phonotactics when we're reading spectrograms. What is phonotactics again? We had a bunch of web pages on them last semester and some this semester. What is phonotactics? That's right. The rules for what the possible combinations of sounds are in a given language. That's phonotactics. So after s, there may be some sounds that are more likely and then some that are less likely. So that takes care of four things here. There are a couple of other rather familiar things here. What are they? Let's look at vowels. Anything look familiar among the vowels? We recognize the vowels right away because what? How do we recognize vowels? They're darker. Let's just start with darker. They're darker. They're down lower. They're not up here in the higher regions like the s's and the sh's, and they're darker. So we know which ones are vowels. At least two of them are very clear. A couple of the others not quite as clear. The first one looks pretty clear, doesn't it? What does that look like? It looks like I, doesn't it? There you go. Were you arguing about that one?
Yeah.
What other possibility were you thinking of?
Sylvie thought it was
Thought.
it was a close-up with a point, so it might be forward.
Oh, I see, because of the beginning.
Yes.
What happens at the beginning of an utterance when it starts with a vowel? How do we usually start a vowel at the beginning of an utterance? With a glottal stop. So that's probably what you're seeing there. But that was not bad thinking, actually. So I. And that takes care of this one, right? So I, four s's, we're making good progress. Is there any other familiar looking vowel pattern here? We'll skip over this one, which is lighter. It's not quite as clear. It's clear in the textbook in this case. But how about another vowel pattern, the next darker one? What does that look like? I'm talking about this one in the book. It's this one here. What does that look like? Because what? Why? You have to have a reason. Low F1 and F2. Okay. But that could also be because of where it's coming from. Is it a steady state vowel or is it a diphthong? Sorry? Okay, it's a diphthong, right? So the back vowel looks kind of familiar, but is the whole thing going to be a back vowel? Because what's happening?
The fullness up from top and down. At the end of the sound.
What's going up?
F2.
F2 is going up. F1 is not, right? F1 is not. F1 goes up a little, it comes down again. So F2 is going up. Does this pattern look at all like this pattern? Do you think? Yumi, do you think so? It's shorter, isn't it? But at the beginning, we're kind of starting off emphatically. So I, blah, 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 blah. Okay. And here, it's going to be shorter because we're in running discourse. It's not going to be quite as emphatic there. That's one explanation. So do you think they look similar?
Yes. So it's another I.
It's probably another I, or something like an I, pretty close to I.
Possible that it is an oi.
Is it possible that it's an oi? Well, for one thing is that oi, is that as common as I? Is oi as common as I? What do you think? Just in your impression. We could Google it and find out probably how common each one is. But just in your impression, do you think I occurs more often in English or oi? I, yeah. Oi is not all that common. We have it definitely. A lot of important words have oi. But relatively speaking, at least as a native speaker, it strikes me that oi is a bit less common. So that's one thing to keep in mind. It looks pretty similar. There may be another reason why it isn't completely similar. What do you think we have after this I or oi? What have we got there? We've got this big white space there, don't we? So what do you think we have? When we have a big white space, there really is nothing there at all. What do you, huh? A pause? A pause? What kind of pause? You mean a pause in the discourse? For example, give me the red one, not the blue one. That kind of a pause? Like a comma? It's not very long. Probably a stop. What kind of stop? First of all, voiced or voiceless? We see no voicing at all, right? We see nothing at all. It's just blank. And that's pretty similar to what we have in the book as well. It's probably a voiceless stop. Now look at our second diphthong there. What do we see at the end of the diphthong? We've got pretty much the same pattern of F1 and F2, but what's happening at the end here when we hit that stop? This is F3 here. So what's going on over there? Yeah. What does that suggest? Pinch. Right? Velar pinch. Now, voiced or voiceless? Voiceless velar stop. We got another answer, don't we? There we go. So I, not so sure. Maybe another I. Someone thinks maybe oi. Oik. Do we have many oik words in English? Let's put that down for a possibility. But ike is more likely than oik. I can't think of many things with oik. The first thing I can think of is oink, but there's no N there. And the other thing I can think of is something called yoiking. That's lap chanting. Lapuzu. Sami. They're called Sami. They're in Sweden. You know them, right? They have a kind of singing, I believe, called yoiking. But that's not an English word, and it's not likely to be here. Latifoket is not going to tell woman to that extent. So I think there's a good chance that this is also an I, and there's a really good chance that's a K. So we've got Ike. Now, Carol is also guessing like. Ooh. Is there anything there that makes us think it might be L at the beginning? In some things, the textbook's a little bit clearer. Look at the textbook one, and let's go back to L's. What do L's, how do L's look on a spectrogram? 250, 1200, 24. Do we have anything like that? Do we have 250? The one in the book in this case, I think, is clearer. Do we have 250? We do. Do we have 1200? Around 1000, right? That looks pretty good. And then how about 24? It's not really clear. The 2400 one is a bit higher. That's right. Okay? So, and it's not very clear, but it looks like there's a really good chance. Should we try L for now? Okay, so we've got I something s, like. Like is a real good find. That's very good work. And then we've got another s, and then we've got that hazy part that's really hard to read. This one's a little better, although that isn't extremely clear either. Let's see what else we've got. Let's go way to the end. We've got an S, and then we've got another S, right? What do you think comes between it? There's a good chance it's a T, isn't it? We see some energy of a released voiceless stop. So it's probably s, 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 s at the end. And we've got a vowel before that. It's not terribly clear. Let's look at the one in the book. What does the vowel before that s, s look like? Actually, the one in the book is quite clear. Well, you can probably guess it. It's right about at the between the 1500 and 1700 mark. Look at that, everybody. What do you see? Tina, anything? We've mentioned a few times in class when we see something with sort of this pattern. It's pretty evenly spaced, everybody. Remember when we've mentioned that in class? If a vowel is pretty evenly spaced, what might it be? It could be, remember we looked at going to schwa, right? Going to schwa. So it's pretty clear in the book. It's pretty dark. Not hugely long, but it could be a schwa, in which case we might guess that this syllable is what? Probably what? A reduced vowel, yeah. It's probably unstressed, okay? And that would make it something like or I, usts. All right, and, all right, is this British or American English? It's British, all right? So we'll have to keep that in mind when we look. What do we have remaining that we can look at? Let's look at the second vowel. So I, what have we got after I? Some kind of stop, and it's got quite a bit of energy after it, right? After the spike. We don't see any voicing, but when the initial stop is a voice stop in English, we don't always voice it unless we really linked it with the first sound. So looking at the energy pattern of that spike after the stop, what do you think it possibly could be? What are our possibilities? PTK, BDG, right? It doesn't look like it's voiced, does it? No, neither one does. Sometimes that fools us though, doesn't it? Because we often devoice things. So let's just go back and look at the stops with their spikes and see if anything looks familiar. We've got a couple of spikes to compare it to. And let's see. Let's look at 205 again. She came, right? She came and then back. Came and back. Does it look like either of those?
It's more likely to be a P.
P? It looks a little bit like a P. It does. Energy looks a little bit lower than here, actually, though. It's right at 2,000. Okay, the frequency looks a little bit lower. Do we have any other? Let's look at page 200. That's a better one for stops. So we've got Pem, Ten, and Keng. Pem, Tem, a 10, and Keng. Does it look similar to any of those? Figure 8.8, bottom of 200. Pem, Tem, Keng. We've got less energy with P, right? More energy with T, and then a bit higher energy with K. This is a little bit lower here. So, what are our possibilities? We're still leaving it at PTK BDG then. Not sure. Okay. Let's look at the vowel after it. Do we have much vowel information? What does the vowel look like? It's clear in the book. After that spike. Okay, the second vowel here. What does it look like? An E or an I, right? That looks very likely because those are pretty easy to recognize. I'm not ignoring you folks over here. It looks sort of like it might be an E or an I. Okay, and it's probably going down a bit, going into this, so it's is with a stop at the beginning. So it could be gis, dis, bis, or piss, tis, kiss. One of those. How about the rest of you? What do you think? Based on phonotactics, what sounds most likely? Okay, is kiss-like a word? Gis-like, bis-like, piss-like. Piss-like sounds terrible. Yeah, that sounds like you don't really like them at all. So, based on phonotactics and meaning, this looks like a pretty good candidate, doesn't it?
But I don't know how to tell because when I saw this dot here, I thought it was definitely because the energy was not really strong and dark. So I thought that was well, it's on the book, but maybe it's darker on the screen.
Yeah. Well, comparing it to figure 8.8, it has more energy definitely than that P. Both of them. Right?
Yeah.
So both of them do have more energy. And of the three, actually, compare it to the 10. Compare it to the 10 in figure 8.8. It's in about the same area. Okay, but this one has a smaller scale, so we have to be careful. And if the vowel is different, that's going to affect it too. Okay? Phonotactically, that's our only choice actually for now. Okay, let's put a D there, and then if we find something else works better, we can come back to it. It's really hard to be absolutely sure of things like stops, initial stops, even voicing or not voice or lack of voicing. You often will not see it because so often voiced sounds get devoiced. So D is the only one that really makes sense here. And that at least gives us some sense for the first part of the spectrogram. I dislike. Huh?
No, nothing.
What was that? What was it, Sylvie? Was that?
No.
So like, spectrograms?
Yeah.
Oh, okay, got it. Well, that's what it is, especially by this point. This is the first one where you're really on your own. This is the most painful. After this, it won't be so bad because once you've gotten through it on your own with a little bit of help, the other ones get less daunting. Yeah. So you've already done a lot, really. So I dislike s. We've got that much, right? And then we've got s at the end. So we've got this confusing stuff in the middle left. What are we going to do with that? I guess I can use the mouse here. So here we go. I, d, is, like, s, and then us. So actually, we don't have much left in the middle. It's this confusing part. How about this? Here's a vowel. Can you all see what I'm marking here? Yeah. All right. That's another vowel. What might that be? We've got a vowel here, right? A vowel here and a vowel here. This one has a clearer form and structure, more familiar one anyway for us. What might that be? At least this part of it should be pretty familiar.
Yeah, it looks like the I.
Let's not look at this part. Just look at this part. This part. It looks like a high vowel. It looks a lot like, which one? It looks a lot like E, doesn't it? This part looks like something's going into the E, and it looks sort of like the I's that we've already looked at. But we've got this little smudge of energy here. We don't have a whole lot of energy here, a lot of clues here, but we've got this here, which tells us the sound before this vowel is probably voiced or voiceless. It's probably voiced, but is it really dark? No. So if we've got voicing right before a vowel, and we've got some marks here as clues, but they're not very dark, what might we have? It looks like there's voicing, and we do have some marks there, but they're not really clear and dark. What might we have? What class of sounds might we have there? What class of sounds? Glides, right. Glides or approximants or nasals, right? Nasals or approximants, something like that in there. Whenever you see those faint marks, like right before or after a vowel, you've got some marks there giving you clues and it looks like there's voicing, then you should start looking at approximants and nasals, right? So from that, do you think that you can get some idea of what's happening here? And how about the end of this high vowel that we've already identified as probably E or I? What do we see here? We see vil or pinch again, don't we? So this is probably what? Do we have voicing down here? Yes, we do. So what do you think we have here? Yeah. How would we say that? Pronounce it. Pronounce the syllable. We've got the vowel, and then we've got plus the vowel. Someone said it. Ing. That's probably an ing there, isn't it? Probably an ing. But what do we do with this very rapidly ascending F2? This F2 shoots up really fast. F3 is not doing anything really impressive here, but F2 shoots up really fast. What kind of clue does that give us? It's a, look at 203. All right, with okay. With we probably would have a lower what? With we normally have a lower F3, right? Does F3 look real low here? No. F2 starts low and goes up high, fast. So it looks on 203 we've got, assuming it's not a nasal here, we've got a few choices more, well, at least one choice more likely than the others. Which one does it look more like? We've got L, R, W, and Y. So if F3 is low, it might be R, but F3 is not low. And if F2 goes up steeply, but F3 also starts low and goes up, then it might be W, because W is similar to R, right? But like we just said, F3 does not start really low. So let's throw out R and W. It's probably not those. And for Y, it could possibly be Y, but does do we see such a steep rise there? F2 starts out high, but here F2, well, it's somewhat similar, but do we have such a steep rise here in F1? Or F2, I'm sorry, I'm getting mixed up. So F2. Okay, do we have such a steep rise for Y? 它会那种陡陡的一下子就上去吗？ Yeah, 不会. So that leaves what? It leaves, again? L, right, okay. Because look at L, it's got a higher F3 coming down. It's got an F2 that shoots up really fast, pretty fast. So that might well be a L. And we've got an energy pattern here that looks kind of light and non-committal. So it seems to fit. Okay, what else can we do? We've now got ling, right? And we've got wists at the end. And we've got a stop before wists, or ists rather. We've got a stop right in here. Look, there's a stop right here. Okay, there's a burst here. Oh, that may not be a burst. It could be from the nasal. But in any case, we've got a stop there. Okay, what do you think it might be? We've got ling, and then we've got ists at the end. So I dislike s, ling, ists. Why not? We need a W for that word, don't we? Do we have anything that looks sort of like a W? What does W do? W has a F2 that rises quickly and F3 that rises not quite as quickly. Our formants are not really, really clear here. But this is the F2 here. This is the F2 here. So apparently, does it look like a W? Does it look like we have a W? But there looks like there's something right before the schwa. Since that 2 it starts low and going up, you can't find F3. Okay, well this is what we have of F1 down here. F2 is going up and F3 should be this. There's not a whole lot there, but right here. Okay? Does that look like a W at all? The 3 is not really clear, but 2 is. And also 1 is. 1 and 2 are pretty clear. Does that look like a W there? look at the W on page 203 again. Third one in the row. So I'm suggesting here, this is a low F1. This is F2, kind of jumping up. And then F3, we don't have that much information. We've got a little bit here. F3 is not as clear. Okay? So what was our guess for this word? Somebody said it, actually. Yeah. That's it. That's it.
I think this part looks a little bit different from the spectrum.
They do. And that's the way spectrograms are.
So because this F2 seems a little bit lower than the one that we have on the book.
Which formant for which sound?
Let's leave F2 that you just pointed.
For the W?
Yeah, because on the scale it's like just right on about 1,000 hertz.
Right.
On our book it's a little bit higher than 1,000 hertz, and I think the place for F3 and F4 is slightly different as well. So
That's true. But I have confirmed this with the author. So, yeah. And he also agreed that this part was not extremely clear, and which is why I made a new one. Parts of it are clearer, parts of it are not. But at least on the one I made, you can see at least that F2 is going up high. And it's making a high F2 with a F1 that's staying pretty low. So it is pretty clearly an I sound. It's going towards I. And we've got a glide in front of it, W. So the difficulties in reading them, that's inherent to reading spectrograms. It's just the way it is. They're hard. When we were doing it at first, I was warning you that when we did actual spectrograms, it wasn't going to be all clear and dark and black and free of Zhen-Yi, like in the samples. When you get to a real spectrogram, so many things come into affect it. But you can still at least make it out on this one for that vowel. So I dislike, and then there's linguists at the end. We've just got a puzzling piece in the middle that's missing. And it starts, so I, d, is, l, I, k, s. And then we've got l, so all we've really got left is this. So here's our vowel. And then here is something that is, again, is not very dark, so it's probably going to be either what? We've got energy, but we don't have as many clear formants as we do for vowels, so this part is probably what? Probably a nasal, isn't it? Okay? What are the frequencies again for the nasal formants? Page 204. Nasals have formants at 250, okay, which we may be considered to have here, and 2,500 and 3,200. These are higher, it's true. How about our vowel here? What does it look like? We do have some. Yeah, the formants for this sound are not really clear, it's true. What does our vowel look like? You got it. This is like hangman, or like Scrabble. Okay? The one in the book truly is not that clear, and it's one that they've kept in the book for a very long time. And I discussed it with Professor Ladefoged, and he agreed, but there it is. Okay, the one I have is a bit clearer, but don't ever expect a spectrogram to be 100% clear. But that is the answer. I dislike some linguists. Oh, what a relief. That was so hard. How could I have gotten that? That's what you feel on your first spectrogram. But as you do more, it gets better. And you don't get so intimidated by it because you usually cannot get all the information at once. You can get pieces of it, and then over time, as you're working on it more pieces make sense, and then it'll come together. Fortunately, you don't have to do this for the test. You may have some things about spectrograms on the test, but I won't give you a spectrogram code, and I said, write this sentence down, transcribe it. You won't have to do that. But this will make an impression on you. So you will remember what it's like, and you also remember some of the cues better. When you're being called on to identify something and you really can't think of it, then you go back and review and you start remembering them better. So this was the first scary experience. The others won't be so bad. Okay? But it will never be 100% easy and straightforward. It never was for Professor Ladefoged, and he was called on to testify in court on the likelihood that this voice matched with the voice of a different person. So he would be asked to testify in court about this, and he could only give percentages of certainty. Oh, he could say, well, I'm 80%. I believe that there's an 80% chance that these two are the same person, for example. So it's not that easy, but spectrograms are still an extremely valuable tool, as you'll find. And don't be totally scared and intimidated from this experience. You've actually done a lot. You've got a lot of the bits before we finally solve the whole thing. And working in a group often helps. When I was working for a 公教机关 a long time ago, our 老板写字很草，他批公文很草。And we tried to figure out, he gave us a 批示, he gave us instructions on what to do. And none of us could get it. So we got in a circle and we held it in the middle. And each one of us identified one character, and then we got the whole thing. Honestly, that's how it happened. It was amazing. And there was one that nobody could get, and I could actually get it. As a foreigner, I even contributed. Because every person recognized something different. So working in a group will help. Not that you're going to have a group at your disposal in the future, but bit by bit, putting the pieces together, and then using phonotactics and grammar and other things, your knowledge of the language, it's doable, okay? Not 100%, not easy, but it's still doable. And it's a good exercise. We've done that. And I'm going to remind you of something before I forget, and that is please bring a scientific calculator to class on Wednesday. We're going to, at least if all goes well, we're going to do the decibels tutorial. Okay, so bring a calculator to class. There'll be a few things that I'll ask you to calculate. Not that many, but a few things that will make it a little more accessible, and it'll feel more doable when you can get the answer yourself. Make sure that you understand the material in the logarithms tutorial. Make sure you're completely familiar with the logarithms. The decibels tutorial is very heavy, and I will not test you on anything unless I warn you about it. And we won't understand everything in it, but 接触过, the next time you run into it, it will be a little familiar and it will be easier. Okay? Feeling challenged is a privilege. You have to remember that. If you had a class where everything was easy, you could probably nap through class and not really bother too much about it. But we really learn a lot of stuff when we do phonetics. There's lots and lots and lots of good stuff to learn. Okay, so we got through this toughie. Let's go on. Let's read in the textbook.
Page 209, the last paragraph. When the vocal folds vibrate, they produce what are called harmonics of...
How do you say it?
Harmonics.
Your stress was fine the first time.
Harmonics.
But how do we usually pronounce an O in isolation? It's got no final silent E, and it's not part of a digraph. It's not like OA, for example. If it's just an O, a plain old O, and it's got a consonant on each side, how do we usually pronounce that in American English? We pronounce it like ah. Everybody please remember that, because that's different from your training. Your training had pieces of British in it. But if you just see an O amid a bunch of consonants, or even just one consonant on each side, there's a good chance in American English that we'll say ah. In British, it will be oh. It will be the upside down A, like in pot. But this is ah in American harmonics.
Called harmonics of their fundamental frequency of vibration. Harmonics are vibrations at whole number multiples of the fundamental frequency.
Okay, we say multiples, not multiples, multiples. There's a consonant before the T, so it's not a tap, multiples. Watch that. if you want to pronounce a tap, check and see if it's a vowel on both sides or an R. R-colored vowel, or just an R and er sound is fine too. But if it's a consonant, it's probably not going to be tapped. Okay, multiples.
Multiples of the fundamental frequency. Thus, when the vocal folds are vibrating at 100 Hz, they produce harmonics at 200 Hz, 300 Hz, 400 Hz, and so on.
And so on.
And so on.
Mark that, and so on. Okay.
And so on. In a given vowel,
In a given vowel,
the particular harmonics evident,
not
evident,
That's better. Good.
are those that correspond to the resonances of the vocal tract shape occurring in that vowel.
Okay, resonances, not ra, re.
Resonances.
Right, okay, so watch your S sound, because it often goes to resonances. Vocal tract shape. And watch shape, everybody. Look at my mouth. Don't say shape, it's shape. Yeah, in Taiwan you learn too much rounding for the sh consonants, sh and ch and j. It's sh, shape. We have some labialization, we definitely have labialization, but it's not rounding like with oo, so shape. Try it again, vocal tract shape. Vocal tract shape. Good. Resonances. Good. And don't say ra. Make your mouth really small. Resonances. Okay, go ahead.
We put two small white squares in the middle of the 5th, 10th, and 15th harmonics in the middle of the vowels in sad and mad.
Middle, not middle, middle.
Middle.
Good.
The vocal folds are vibrating at about 118 Hertz in sad.
And sad.
In sad.
Okay, the little song, because it's a tonic stress, we start high. Sad.
Sad. So the 5th harmonic has a frequency of 5 times 118.
118就可以了。
118
Good.
equals to 5
Equals 就好了。
equal 590 Hertz.
Good.
The 10th harmonic frequency of 1180 Hertz.
How do we usually read that? 1180就好了。
1180.
Yeah.
1180 Hertz, and the 15th harmonic a frequency of 1770 Hertz.
Good. Frequency.
Frequency.
Good. Watch the N. Everyone, frequency. In Taiwan English, you often just leave a nasalized vowel there. You have to watch and listen to get this. Everybody watching and listening. Taiwan English will often have frequency. No N. Just a nasalized vowel. Frequency should be frequency. We care about that actually. Frequency. Even though a native speaker probably can't tell you what's wrong, it'll sound weird. Let's first of all look at the narrowband spectrogram, which shows us the individual harmonics. And the place where we see those white squares, it says that the F0, the fundamental frequency, is how much? A 118 Hertz. Okay, and it's this vowel in sad is pat sad. It's sort of like 1/3 of the way through, almost to the middle point. And they have marked with white squares the 5th harmonic, which will be at 590. Do we see a harmonic there at 590? Look at the first couple white squares there. Yamil. Everybody know what I'm talking about? If you don't, let me just show it here. We're looking at these pairs of white squares. They put 2 of them to show that it's something of a steady state for a while. So the fundamental frequency is about 118. And if we go up 5 harmonics, the 5th harmonic is around, it should be exactly 590. So can you count 5 black stripes up to those first 2 white boxes? 1, 2, 3, 4, 5, exactly 5, right? Now keep counting and go up to 10. So that's 5, 6, 7, 8, 9, 10. It's a little hard because they're moving a little bit, but can you see that the next place where they have white boxes is at the 10th harmonic, the 10th black stripe? Yomel. Okay, keep counting up. 11, 12, 13, 14, 15. Is that right? The third pair of white boxes is at the 15th harmonic. It should be at about 1770. And is it? Can you, if you have a nail, it helps. If your nails are too short, it's harder to count. So from about 1180 to 1770. So those are the first 15 harmonics. If the fundamental frequency is 118. Okay. Now, it's kind of fun to see those stripes so clear in the narrowband spectrogram, isn't it? Actually, you can adjust for WASP. You remember WASP that we used a long time ago? You just pick either wideband or narrowband, and they've already adjusted it for you. But with PLAT, you can pick whatever level you want. You can have it not wideband and not narrowband. You can pick something in the middle. So there will be instructions with WASP. If you look at the tutorial or if you Google it, it will tell you how to adjust the settings so that you can get a narrowband spectrogram. That's what I did when I gave that demonstration with the little 3-pitched horn, remember? So I adjust the settings on PLAT. You look it up, it will tell you how to do it so that you get finer resolution in which dimension for narrowband? We've got much finer resolution in which dimension for narrowband spectrograms? Frequency. The frequency is really clear. That's why all of the overtones, the harmonics come through so clearly. Or if we resolve it really clearly in time, then it'll be like the one above it, which is a broadband spectrogram. So depending on what kind of resolution we want, we can't get both at once. It's just because of the way physics works. We can't. So you pick what you want. If you want to see the changes of a sound in very fine resolution in time, if you want to see the individual vibrations of the vocal folds, pick a wideband. Or if you want to see pitch and tone, pick a narrowband. And you can see the pitch going up and down. All right? Let's see. That was the bell. We'll stop there and continue after break. Page 210. Okay, two things. We'll probably finish the chapter this hour. We're going to be done with 8. And we can save time if we include all the 3 remaining chapters in the final exam rather than taking a separate test for 8. However, if you really want a separate test for 8, I can do that too. That means a bit less pressure for the final exam. Chapters 9 and 10 are not that difficult. After 8, nothing's difficult. No. If you've survived 8, you're not going to have problems. They're not that difficult. 11, remember, you need to read 11 on your own. I told you at the beginning of the semester, we're not going to do it in class. Read it on your own. Take a little bit a day. You can start it now. Just finish reading chapter 11. I may put 1 or 2 questions on chapter 11 in the final. You need to read it. But we are not going to cover it in class. I'm going to ask you if you have questions. So after you've read it, bring your questions to class and we can answer them in class. But we're not going to read it in class. So would you really prefer a separate test for chapter 8 or should we lump them all into the final? That would save time. That means more class time for learning rather than testing.
When will we have chapter 8 if we separate it from the other chapters?
When would we have the test, you mean?
Yes.
I haven't thought of it because I'm assuming you're going to put it in the final.
Okay.
If you really insist, I can do it. The reason is because we really have very little time left. I think we have enough time to finish 10 without much problem, but we can't drag our feet. We have to move along. And I also have, in addition to the decibels tutorial on Wednesday, there's a very fun tutorial or web-page lesson on musical instruments. That one's really fun. And we need 1 class hour for that. 那个错过太可惜. When is the final? I'm sorry, you'll have to check. I think I put it on the syllabus, which I have not been updating lately. I had trouble updating the syllabus for one class, and then I stopped updating all classes, but I'll have to make up for that, I'm afraid. Okay, I don't want to spend time on this because we want to finish the chapter. If you have any strong opinions on it, I will consider them. I think basically we can get more learning done if we put it all in the final. Make sure you understand everything. Any questions you have, bring them to class. Go through the whole chapter carefully. Go through the whole chapter carefully. We're finishing hopefully today. Go over the whole thing. This is an assignment, and put it in your notes for Monday. Put it in your notes for Monday. Notes on chapter 8, Ladefoged, because you really, really need to do this, especially if we're going to skip a separate test on this chapter. Go over the entire chapter 8. Put it in your notes for Monday. Okay? And so Sophie and Mendy, take a note of that. Make sure that they include it. And it will feel good going over it the second time because all this difficult stuff is no longer so difficult for you. There'll be some little parts that may be hard. Bring questions on those parts to class. Okay, so when you're going over chapter 8, write down your questions, bring them to class. Let's try to clear up everything that we can. Okay, and don't forget your calculators for Wednesday. And, the other thing was some people will need to miss class due to drama. Is that right? Try to miss as little of class as possible. If you can get out of it, if you really absolutely have to be there, if you can do it, if you can escape early, because honestly, this stuff, you really need to be in class to do it. Okay, so please try to get here for as much class as possible. If you have to miss a class and you tell me ahead of time, I absolutely have to miss this class, 我们可能要补课，可能要想办法补课。Because I sort of am calculating with the number of hours that I thought was left, not with some hours missing because of theater, okay? All right, so put that in your notes too. Let me know when you absolutely will not be able to come. And if so, we may have to make up a class. Okay, let's continue unless there are any questions or if there's any discussion. Let's go on.
The first formant in SAD is formed by the fifth and sixth harmonics, and the principal components of the second formant are the 14th and 15th harmonics.
Okay, there are two things that we could improve. You read quite well, but two things regarding intonation you could do better. And both of them have to do with how you finish an utterance. So the first formant in SAD is formed by the fifth and sixth harmonics, your continuation rise before the comma, and then your tonic stress at the end of the sentence. So I'll read the whole thing and then you try it again. The first formant in SAD is formed by the fifth and sixth harmonics, or you could say fifth and sixth harmonics, and the principal components of the second formant are the 14th and 15th harmonics, because harmonics is going to be repeated. So we can kind of presage that by de-stressing harmonics the first time. The first formant in SAD is formed by the fifth and sixth harmonics, and the principal components of the second formant are the 14th and 15th harmonics. So we've got two sets of contrast here. What are they? First formant with second formant, and the second set is fifth and sixth harmonics with the 14th and 15th harmonics. So you need to make both of those correspondences clear, both of those contrasts clear. Can you try it again?
The first formant in SAD is formed by the fifth and sixth harmonics, and the principal components of the second formant are the 14th and 15th harmonics.
14th and 15th harmonics.
14th and 15th harmonics.
Because teen is also repeated, right? So we can de-stress teen to 凸显, the fourth and the fifth. We can make those even more 明显. So try it again. And the principal?
And the principal components of the second formant are the 14th and 15th harmonics.
You sound a little unsure here. Listen. And the principal components of the second formant are the 14th and 15th harmonics. I'll do the whole sentence again. Everybody kind of turn on your tape recorders. The first formant in sad is formed by the 5th and 6th harmonics, and the principal components of the second formant are the 14th and 15th harmonics. Try it again.
From the start. The first formant in sad is formed.
In sad, that's new, and
in
it's a tonic.
sad is formed by the 5th and 6th harmonics, and the principal components of the second formant are the 14th and
Go up high.
14th and 15th harmonics.
You did it. Harmonics.
Harmonics.
Good, you got it.
Compare this with the vowel in mad, which has in mad.
When we have a tonic, we have to go up high, and we exaggerate a little bit. So compare this. This is also a shao tonic. So because we have contrast here, 这个拿来跟那个来做比较, right? Compare this with the vowel in mad, or this 也可以不要那么重. Compare this with the vowel in mad 也可以，不同的诠释也可以. Okay?
Compare this with the vowel in mad,
Good.
which has formants very similar to sad.
Formants 不需要太重 because formants gets repeated over and over again, which has formants very similar to sad.
Which has formants very similar to sad.
Good.
Both being
Both is an emphatic word. Watch out for both. 两个都有. It's emphatic in Chinese too. So watch out for both. It tends to be emphatic. Okay?
both being examples of the a phoneme.
Good.
Near the beginning of the last word, the third harmonics is the
Third?
third
is right.
The third harmonic
Yeah.
is the principal component of the first formant, and the eighth harmonic eighth harmonic the principal component of the second formant.
Very good. Now you've got the contrast down. 现在很漂亮了. Except for we may not have understood. So let's look at the first formant in sad. Now we're looking at the formants. These are the thick black bands, not just the black overtones, right? If we're looking at the narrow band spectrogram, you can also look at the wide band. So everybody look up here just to make sure you're doing the right thing. We're now looking at the thick formant bands, which are composed, they've also got sort of superimposed on them, or actually it's the formants are superimposed on the harmonics, not vice versa. So we've got the formants, we've got the overtones there, which appear quite clear, and then we've got the thick bands of the formants appearing over that. It's an overlay over the overtones. So let's just follow sentence by sentence. The first formant of sad, here's F1 of sad down here, right? It's formed by the fifth and sixth harmonics, and we've already looked at that area. That's where the first pair of white boxes are, right? So F1, sad, no problem. And that's, if you count, we'd already counted the fifth and sixth harmonics. And the principal components of the second formant are the 14th and 15th harmonics. We've already counted up that high, haven't we? So we don't have to count again. So we've got the fourth and fifth, the fifth and sixth harmonics, and then the 14th and 15th harmonics making up F1 and F2. We're going to then compare that, have we read that yet? Yes, we have, with the vowel in mad. If you look at the white boxes in mad, it's not as clear because the bands are wider and we've got wider spaces, wider white spaces there. So compare this with the vowel in mad, which has formants very similar to sad because they are both a, right? The phoneme in both cases is a. But in this case, the harmonics are higher, but are the formants higher? Look carefully at those two pictures and you can compare them with the wideband spectrogram above. You can see that the harmonics are going to move farther apart in mad, right? 它的背音它会间隔比较宽，对不对? But how about the formants? Do they move around? Because both of them are a. Do the formants move around the way the overtones do? Look at it carefully. They don't. The formants are stationary, aren't they? Because we're doing the same thing with our vocal organs to produce a, even if our pitch is higher. Is Pat sad? You have to kind of watch me because I'm being a director up here. Is Pat sad or mad? Mad is going up high because it's a tonic, right? So that means the pitch is going to be higher. And that means the fundamental frequency is no longer 119. It's going to be a lot more than that, quite a bit more than that. Maybe it's going to go up to whatever it is, maybe 280 or something like that. It's going to be pretty high. So that means that the overtones are going to be spread out more. So if we mark the fifth harmonic in mad, is it going to land on F1? 我们原来在 sad 的时候，我们数到第5个倍音，对不对？然后呢，它刚好是在 F1 上面，对不对？然后如果我们做同样 sad， 我们就数到第5个倍音。第5个倍音是不是刚好那个 F1 的地方？ No. The fifth harmonic is now higher than F1, isn't it? Because they're more spread out. So they're going to move up on our scale faster. So that's what he's showing you. The harmonics are going to vary according to our F0, to our pitch. The higher our pitch, the more spread out the harmonics are going to be. They're going to go up higher. And then the spaces between them will be much wider. But the formants stay in the same place because there's something imposed on the overtones. Whatever overtones our vocal tract gets, it just works with them. 它听到它的共鸣，它就加强；没有它的共鸣，它就算了。So F1, 2, and 3, the formants are all going to stay the same. But the overtones are going up higher because we have a higher pitch. And then you can see when they are superimposed on each other what they look like. Okay? Is that clear or not? Does anybody need it explained again in Chinese or not? Are we okay? The nodding means it's clear already? It's already clear. Good. Then we can keep reading.
As we have noted, the quality of a vowel sound depends on the frequencies of the formants, but the pitch depends on the fundamental frequency, which is determined by the rate of vibration of the vocal folds.
Good. You can put a little more voicing in the V's. Rate of vibration of the vocal folds. Try.
The rate of vibration of the vocal folds.
Good. That sounds more like a V. So, for F1 in the case of mad, we've only gone up to which overtone? Mad, 那个 F1. 它在, yeah, it's only the third overtone. We're already to F1. That's what they're saying here. They just want you to understand that the overtones and the formants are independent of each other. So 互相是独立的，独立作业，互相没有什么关系。They operate separately. Next.
In women's voices, in women's voices, which usually have a higher pitch, the formants are sometimes more difficult to locate precisely.
I say locate. Locate is not wrong. Locate. Locate precisely.
Locate?
Locate.
Oh, locate.
Because Kate, if we stress it, it's just too close to another stress. And I say locate anyway. Locate. To locate precisely.
Are sometimes more difficult to locate precisely. Figure 8.17 shows spectrograms. Spectrograms. There we go. Shows spectrograms of a female speaker of American English.
Female speaker 你刚刚没有放重音，可以放重音。Of a female speaker.
Of a female speaker of American English saying the same set of vowels as those of the male speaker. Male.
Good.
As those of the male speaker in figure 8.3.
Actually, it's 8.4. Page 194. It says 8.3 on the CD, but the book says 8.4. All right? So these are the same vowels. But what differences do they want you to notice here? Look at those spectrograms in 8.17. Do you notice a bunch of white waves there? 有没有看到一些白色的波浪的东西，好像在干扰那些 formants 的样子？有没有？ What I'm looking at here, everybody, you can see these white lines here. They seem to be interrupting the formants a bit. 就是白色的那些波浪。Okay. Let's go on.
Even though these spectrograms have been made with considerable care,
Right.
choosing the most appropriate degree of appropriate.
Remember, 形容词名词 at 要念 at.
Choosing the most appropriate degree of narrowness of the spectrogram to best show the format frequencies. The harmonics still interfere with the display of the formats.
对，尤其是 U 的时候，你看到很多空白的。Compare that to the U on page 194. 194那个 Peter Ladefogel 念的 Oh no, this is American, it's probably Bruce. 比较清楚 and you can see a lot of white lines or white spaces. And this one, 就是它的那个背音会干扰，间隔比较宽，它就会干扰到 format 的显示。
Notice, for example, the change in vowel quality in the vowel which appears as a series of steps as different harmonics become available to make up the format.
Okay, so look at in 8.17. You can see those white lines because is very diphthongal in American English. This is an American speaker. So like put. It's very diphthongal. And then the pitch is going to go down to put, probably. Okay, so the 背音 are going to interfere.
In a narrowband spectrogram, it is even more difficult to It is even more difficult to locate the centers. It is even more difficult to locate the centers of the formats when the fundamental frequency is high.
So what they're saying is here is if you look at the narrowband spectrogram in 8.16, the higher the pitch, the wider the overtones are from each other, the more further apart they are from each other. And the further apart they get from each other, 它可能刚好该显示 format 的地方是空白的，因为你的间隔很宽。Is that all clear? That's what they're talking about here. So if you have a very high-pitched voice, a very high-pitched female voice, and you want to use a narrowband spectrogram to show the formants, a lot of the data will be missing because the harmonics are so high. It's going to leave big white spaces between them. Carol, make sense?
Yeah, I'm trying to
process
write
it.
down.
Somebody repeat it again in Chinese, please. Anybody?
就是如果它的 pitch 比较高的话，它的 overtones 里面的就之间的间隔就会比较大，那这样子的话就有可能在 formats 的地方就找不到 overtone， 这样。
对，就是你要有 format， 你必须要有一个 overtone 在那边，会刺激它。那你刚好那边是一个空白的地方，那 format 该显示的地方就会变空白的，因为 overtones 的间隔变得很宽的时候，变成说很多一片一片的那个白色，一条一条的白色，刚好你该显示 format 的地方刚好是 overtone 的白色的部分，format 就显示不出来。Did that make it better? Okay. Time will help as well. Let's go on. Very often, when you've slept on it, the next morning suddenly it becomes clear. Sleeping is really, really important in learning. But not right now. Okay.
Narrowband spectrograms are obviously useful for determining the intonation or tone of an utterance. One can do this by looking at the fundamental frequency itself, but when this goes from, say, 100 to 120 Hz, the frequency of the 10th harmonic will go from 1000 to 1200 Hz,
which is much easier to see.
All right, so if we're just looking at the fundamental frequency, if it's going from 100 to 120 hertz, that's a difference of how many hertz? Only 20, but if it's going from 1,000 to 1,200, it's a difference of, 200, so that will be clearer, that will be easier to see, okay?
The actual pitch, or to be more exact, the fundamental frequency at any moment will be 1/10 that of the 10th harmonic.
1/10 that of the 10th harmonic.
1/10 that of the 10th harmonic.
Which is 废话, right? 1等于是1/10乘以10这样子等于. Okay, so you count up to the 10th harmonic just to see where it falls, what the frequency is, because if you try to count way at the bottom, 下面挤在一起不清楚. Count up to the 10th harmonic, you found the frequency, then divide by 10, then you can get the fundamental frequency, right? Okay, it's just a way of finding a clearer marking of the fundamental frequency through the overtones, okay?
As we saw in
Saw in. There's no real linking. We don't link that much at all, just saw in.
As we saw in chapter 5.
5. Good.
Computers can analyze speech to give a good
Pause after speech.
Can analyze speech to give a good record of the fundamental frequency, the pitch. But most fundamental frequency routines make occasional errors when the pitch is too low or when the vocal folds are not vibrating regularly.
Good.
In these cases,
in these cases, there's contrast. In these cases,
cases, a narrowband spectrographic analysis can be very useful.
Oh, you read beautifully. I can hear you applying the rules. You're thinking and you're correcting, and you sound great because you fixed just about everything. It sounded really, really good. Yeah. So it works. You know, if you learn the rules and you practice, you think about it, you go through a period where you have to think hard, but eventually it becomes habit, and then you sound really good because then it sounds really spontaneous. So this is something that we can do when we can't rely on the function of the software called pitch track. So remember when we used WASP, there was a function called pitch track, and of course we also have it on POT. It traces the pitch. It shows you what the pitch was of the utterance, gives you the intonation. But there are a couple cases where it is not always accurate. The pitch track is not always accurate, especially in which two situations that he mentions. First, right. So the computer, the program has a 计算的方式，它来计算出大概那个 F0 是多少。不是很 straightforward. It's not just recording and then it gives you automatically the F0. It's using a rather complicated method to try and guess what the F0 probably is. It's easy with vowels, right? Because they're voiced. When it's voiced and it's clear, no problem. But the first situation in which it's going to have problems is, Sylvia, I'm sorry? The pitch is really low, it's going to have trouble. It just has trouble recognizing the F0 if the pitch is really low. That's case number 1. And case number 2 comes right after it. Vibrating regularly, and that means, for example, in what kinds of sounds? Voiceless sounds. Yeah, voiceless sounds are terrible because voiceless sounds really confuse pitch track because they have pitch, but where are the pitches? Where are the pitches for sh and s? Are they in the range of the pitches for vowels? No, the pitches for vowels for F1, 2, and 3 go up to about what? Just look at the pictures, look at the figures. Yeah, they go to about 3,000. We don't need much beyond that. So usually we just cut it off at 4,000. That's the area of vowels. But what is the domain of fricatives like s and sh? Yeah, and above, 5,000 and above. It's going to go up to 12,000 possibly. They go very high. So it will give pitch information to the pitch track, but is it F0 information? Is it F0 information, that pitch information it's getting? It's getting? No, it's fricative information, right? Because we have no voicing. We can't get an F0. There is no F0. 根本没有 F0. So it's going to make a lot of marks. For example, pressure. What's it going to do during sure? It doesn't know the pitch because there is no F0. There's no vibration. Pressure. So we can have some kind of an algorithm, some kind of a 计算的方式 that maybe guesses if we start it can maybe just draw a smooth line from the first vowel to the next vowel. Make sense? Yeah? So it has to have a very clever mathematical formula for getting from pre to because sh is not going to help us. It's going to give us erroneous, misleading data about very high pitches, which have nothing to do with F0, because there is no F0. But we also like a nice connected line. So a pitch track will try to do that through a 计算的方式. And sometimes it's pretty clever, but it's very, very prone to error. And you can't blame the programmer. They did their best. There is no F0, so what can you expect? They're just doing their best. Everyone's clear about that? So when we're using pitch track, we're going to get a lot of errors. He's spending his time here in this part of the chapter to tell you about the uses of what? What is our main point here? Narrowband spectrograms. So when you have problems with your pitch track data, use a narrow or have it display a narrowband spectrogram, and then you can get all kinds of data on F0. Okay? Can you give me some feedback? Carol's kind of taking the responsibility here. How about the rest of you? Tina, is it okay? Good. Let's keep going then.
We may now summarize the kinds of information that can and cannot be obtained from spectrograms.
Okay, pretty good. You can emphasize it even more. You know that it's a contrast, but you can say that can and cannot be obtained from spectrograms. So listen to the whole thing. We may now summarize the kinds of information that can and cannot be obtained from spectrograms. And watch the vowel in obtained.
We may now summarize the kinds of information that can and cannot be obtained from spectrograms.
Okay, obtained.
Obtained.
No.
Obtained. Obtained.
Good. And then spectrograms.
Spectrograms.
Now it's great. Good.
The most reliable measurements will be those of the length.
Watch the voicing.
Those of the length of the segments for which purpose spectrograms are
You're missing that k sometimes. Spectrograms.
Spectrograms
There we go.
are often even better than waveforms.
Better.
Better.
I'm being really picky here. Better.
Better.
Everybody, better. Better. Don't say batter. Batter is 面糊. And you know that famous tongue twister, right? Betty bought a bit of bitter butter. And she said, if I use this bitter butter, it will make my batter bitter. Okay, so if I use the better butter, then the batter will be better, or something like that. So it's good for practicing and ah. And that's one of the remaining problems that some of you, I think, still need to work on. Keep your jaw up. Everyone, better. Better. Spectrograms. Spec, not spac. Spectrograms. Okay, measurements. Good, go ahead.
Differences among vowels, nasals, and laterals
And
laterals can be seen on spectrograms, whereas it may be impossible to see these differences in waveforms.
in waveforms.
In waveforms.
Right. So now we finished our subtopic of narrowband spectrograms, and we're going back to spectrograms in general because we're summarizing because we're getting to the end of the chapter. Okay, not much left. What are spectrograms really good for? They're most reliable for measuring the length of segments. 所以一段音要有多长? Spectrograms are really good for that. And even better than waveforms. You can see the individual pulses really clearly. And we can also tell pretty clearly the difference between vowels, nasals, and laterals on spectrograms. We can usually tell the difference between vowels on the one hand and then nasals and laterals on a waveform. But nasals and laterals are not easy to distinguish on a waveform. So here he's talking about the advantages of using a spectrogram over a waveform. Vowels are pretty clear. Nasals will have a much smaller amplitude on a waveform, but we see the formant structure and data much more clearly on a spectrogram, and so we can get a lot more information. Okay?
Spectrograms are usually fairly reliable indicators of relative vowel quality. The frequency of the first formant certainly shows the relative vowel height. The relative vowel height quite accurately.
Beautiful. Vowel height is right. Accurately. Everyone, accurately. This is F1. Remember that F1 corresponds to vowel height, and it's a pretty good indicator of vowel height. It works pretty well. It's quite reliable. F1, vowel height. And continue. This is also probably going to be in the test.
The second formant reflects the degree of...
Not reflects, reflects.
Reflects.
Reflects. Reflects.
Reflects.
That's better. Everyone reflects. This at issue is probably something you should put in your notes, put it in your pronunciation plan, really work on it. It's almost universal in Taiwan English. Not every single person, but a huge number of people. And it really takes work because, in my experience, it's hard to hear the difference clearly and then to reproduce it. But you can do it. Just make your mouth really, really mun for the reflects. That was good, Carol. That was it. That was it. Keep that. That was good. Your reflex was very good. Yeah. Yeah. Everyone reflects. That sounded good. Okay.
Reflects the
Good.
degree of vagueness quite well.
Quite well.
Quite well.
Not
Well.
quite.
Quite.
Uh-huh.
Quite well.
Uh-huh.
But there may be.
Stop it, stops.
But there may be confusions due to variations in the degree of lip rounding.
Lip.
Lip rounding.
Right, good. And variations was perfect. It was my dialect at the time. It was not variations this time. It was variations. That's exactly as I say it. So F1, tongue height, very reliable. F2 tells us something about backness, but is it really reliable? No, because of lip rounding, which will push the formants down. There we go. Remember that stuff. Make sure you know this really, really well. Why don't you take another one, Tina?
It is also possible to tell many things about the manner of articulation from spectrograms.
Oh, good. The spec is perfect now. You got it. You got it.
For example,
For example,
one can usually see whether a stop has been weak.
a stop. If you're going to
stop.
stop yourself, you need to have a continuation rise.
Whether a stop has been weakened to a fricative or even to an approximant. Approximant. Affrication of a stop can be seen on most occasions.
Okay, so these are other things that we can see pretty clearly in a spectrogram. Number one, if a stop has been weakened to a fricative, it's no longer a nice sharp stop, but it becomes s, for example, instead of t. Or maybe it's even an approximant, so from t to s, to something else like that, or e to y. Okay, that's starting from a vowel. But in any case, the further your tongue gets away from the other articulator, the more weakened it becomes. It's going to go from a stop to a fricative to an approximant. Okay?
Trills can be separate from flaps, and voice from voiceless sounds.
Voiced from voiceless sounds.
Voiced from voiceless sounds.
Good. So affrication of a stop can be seen on most occasions. For example, T and T, T and T, T, right? And remember with palatal stops, ja, ja, and ja. Remember those? Those easily get affricated from tia to tia, 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 tia to tia, tia. You can hear some frication there, affrication. You can see that clearly on a spectrogram. We can separate trills from flaps or taps as well. Remember, ara, curl up your tongue and then open it up. From back to front, that's a flap. From going up and down again, that's a tap. They can be distinguished from trills, which are at least 3 pulses of the tip of the tongue, rrr, if it's an alveolar trill. And one thing we can tell pretty clearly is voice from voiceless sounds. However, we often devoice voice sounds, so we have to watch out for that. Okay?
One can also observe the relative rates of movement.
Relative rates. Relative rates of movement.
Relative rates of movement of different articulations.
Yeah, how fast they're moving. Like when we were looking at that spectrogram today, you can see if there's a really quick rise or if there's a more gentle rise, or how long the vowel is being held and so forth. Okay, next reader.
Spectrograms cannot be used to measure degrees of nasalization.
Nasalization.
Nasal-
I is not wrong. I just say it.
Nasalization, nor are they much help in differentiating.
Differentiating. There, yeah.
Between adjacent places of articulation.
Places of articulation.
Places of articulation. For studying these aspects of speech, other techniques are more. Other techniques are more useful.
Very good. So, one thing that spectrograms are pretty weak at, and waveforms are also weak at, is measuring degrees of nasalization. 它鼻音化到什么程度，有点不容易看出来. Remember that nasal formant structure nasal formants show up pretty light on a spectrogram, don't they? 是蛮淡的，而且会少掉一些母音会有的 formants because we've got these anti-resonances. So for nasals, the data is not going to be clear. It's not going to give us much information on 鼻音化，就是鼻化的程度。Or even 它是哪个鼻音要看运气. Sometimes it will be clear, sometimes not so clear. And it's not very good for differentiating between adjacent places of articulation. We need usually bigger contrasts to be able to identify things on a spectrogram. So if it's going from an alveolar T to a dental T, you probably will not see it clearly. Alveolar to dental, it's too close. Usually we need bigger contrast to see them clearly on a spectrogram. It may not reflect it really clearly. And if we want to study these things, there are other techniques, and you've learned about some of them already in vowels and consonants. So we're now on what I believe is the last section of the whole chapter before the exercises. Let's go. No, that's okay. You can continue. It was a little short.
Individual differences.
Individual
differences.
Okay.
The last subject that must be dealt with is this chapter. In this chapter, is that of differences between individual speakers.
Individual. 不是这，这是什么的这 Individual. Yeah.
Individual.
Right.
Speakers. This is important for several reasons.
Several reasons.
Reasons.
All right. EA 那个自然发音法 EA is usually E, sometimes A. Okay.
First, we often want to know whether a particular speech pattern is typical of a speech community or whether the speaker might have some kind of idiosyncrasy.
You did it. Everybody, idiosyncrasy. 那是个人的怪癖 idiosyncrasy 这个某一个人真的很怪的地方 Okay.
Second, When trying to measure features that are linguistically significant, one must know how to discount purely individual features.
Almost individual.
Individual
More j.
individual
You got it. Jewel.
individual
就像珠宝 jewel individual.
individual features. Third, now that acoustic analysis
Sees.
of voices are used in forensic situations.
Much more. It's like individual situations.
Individual situations.
There you go.
We must discuss the validity of speaker identification.
Very good. Wow, that was really good. So finally, we're going to talk about 个人的不同. We've been talking about the shared core that we all pretty much have if we're a native speaker of English, if you're a pretty good speaker of English, or even if it's another language. All this stuff applies pretty much. But now we're going to talk about 个人的不同. First of all, maybe it's not 个人,而可能是他自己的族群的特色. So for example, I keep talking about my British friend. He would hear somebody speaking and he'd go, oh, sounds just like Karen. But then he found out all Americans talk that way. He got so used to my voice, he would hear somebody go, wow, it sounds just like Karen. Of course it sounds like Karen because it's an American. That was kind of funny. And then after he started hearing more and more American women speaking, it was less of a big deal. Okay, so we also need to be able to distinguish different levels. So first of all, what we all share, then things that a community has in common. 这个族群. For example, 台湾北部人, they have a lot of things in common, or people, especially of a certain educational level. 就是教育程度到某一个程度以上，然后是台北地区，讲话应该有很多共同的地方，可能跟南部有点不一样，可能跟大陆有更多的不一样，对不对？ Right? So that's what we mean by 族群, a certain community of people. Community does not mean you live exactly in the same village or the same neighborhood. It's a group of people with things in common. So community here 是广义的，英文比较会用这种广义的用法，中文社区没有这个意思，除非就说有点受英文的影响。So 某一个族群 So we need to be able to identify 这是族群的特色 Just like when my British friend thought that, oh, this person sounds just like Karen, it wasn't 他个人刚好跟我个人的一些东西一样，是刚好我们的族群是一样的，同一个族群。Or 是不是还是那个人的怪癖，那个 idiosyncrasy， 他非常个人的一个特色。For example, someone I know makes a lot of 口水声 when she speaks. So I can't even imitate it when I want to, but when I'm recording, then it all comes out. So she just makes a lot of smacking sounds when she's speaking. 一直很多口水声。I don't want to, 我不要学她，因为我怕我录音的时候那个受感染，然后收不回来。But that's one thing. 这个人的特色，他的口水声特别多。Or it could be they speak in spurts. Well, I went to see my friend, and then we went out and had lots of fun, and then we came home, and then some people 这是个人的一个怪癖，这是个人的一个特色。So that's what we mean by idiosyncrasy. 这是个人的某一个特色。Or maybe they're really nasal when they speak. Not everyone is this nasal. So this person is especially nasal. Okay? 这些都是一些个人的 idiosyncrasy. Okay? And when we want to measure features that are linguistically significant, 我们要去测量一些语音上有意义的一些特征的时候，我们必须要去掉一些个人化的因素。When we want to generalize, if we want to write a description of Mandarin Chinese, Taiwan Mandarin Chinese, or American English, or whatever it is, or Tokyo Japanese, whatever it is, 我们必须要去掉很多那种个人的比较奇怪的地方，要不然我们的 description 会变成是个人的 description， 而不是某一个语言的 description, right? So that's what we're talking about here. How to identify and then, when necessary, to discount some individual features. And Finally, we're going to talk about the validity of speaker identification, which I mentioned before. Some people call it 声纹, and we mentioned that it's not like fingerprints. It's not as unique to each person. It cannot be used like fingerprinting as with as much absoluteness as fingerprinting. So we can't look at a spectrogram and then say, well, I'm sure it's that person, the way we could if we had their fingerprint. It just doesn't work that way. Okay, we have stopped right at the end of a paragraph. The bell has rung, so we'll have to finish on Wednesday then. We didn't quite finish. I was a little over-optimistic. Do the exercises. It's time to do the exercises. Now, in the next one, you're also going to have to try and read a spectrogram. He's given you some hints. Every year we've gotten it, but usually it takes, you try hard, you get some of the segments yourself, bring it to class, and then just like the process I described, everybody contributes a little bit and then we get it. That's what will probably happen. Occasionally someone gets the whole thing by themselves, but it doesn't happen very often that way. Usually they get parts of it, maybe a good part of it, maybe about, say, 2/3 or more of it, and then we finish it in class. But do your best. But don't get really angry or upset or scared. That doesn't do any good. Do what you can, and if you can't, then let it go, and then look at it later, and if you still don't get it, no big deal, okay? So that's for A, and then for B, they give you the sentence, and you need to, you need to transcribe and then segment the spectrogram. You need to transcribe the sentence onto the spectrogram and then mark where the segments start and end. And then we're going to do something similar for the waveform in C, and we'll have to figure out how to mark this. In other years we've put it on the board, or we'll figure out how to mark it. And then it says, using a speech analysis program like WaveSurfer, we're using Plot. So use Plot for this. And then just follow the instructions. Then you'll need a calculator for some of these things, but we've practiced them in class, so go back and review and they shouldn't be a problem. And then, okay, then just follow the instructions for the rest. Don't get too frustrated. Put it down if you get frustrated, but don't just say, oh, I'm frustrated, and put it down. Okay, give it a good shot. So, what do you bring on Wednesday? Bring a calculator, right. We'll finish the chapter, we'll do the tutorial, and then we'll see what happens. Okay, we'll see you on Wednesday.